Okay, now that we have a GUI or something similar to this, built on your own design, with discussion with your teammate, now we have to make something happen after I've entered data into here, such as I'll just make up some data. Account 123, cryptocurrency amount 1,000, type of transaction, sale, description, my computer, account name, I'll call it Manning, and some recipient. It could be their email. I haven't decided what recipient is. Maybe we'll just call it their account number. Now when I store the data, I want something to happen. Initially, I'm just going to have some kind of debug message showing what the string of data would look like to go with this information. So when I click on this, I don't really do anything regarding blockchains. I do generate a string though, and we see here my string is a comma-separated set of strings. Easily turned back into an array for processing by doing a split with the comma as my string delimiter. And you can read about split, or you can read about split with strings. You should have covered that in strings. If not, look it up yourself in the reference manual or online. I'm not going to worry about that right now because all we're worried about is storing the data into our blockchain, and the rest is learning about how blockchains work. But let's just see how we made that connection. I click on that button, make something happen. Here's where it's all done. I create this button, and before I can do a new store action listener, I have to define this. That's something that I write, that you're going to write. And you can use this code and refine it, and probably if there's going to be some things missing that you need to change. But let's see now how in the world we create this action listener, because that's how you make something happen when you click on a button. You have to add the action listener. That button store was a J button defined up there, given a new J button object with that string that will appear on the button. Now, here's how we define what happens when I click on that button. I have to define my variable name that I chose to give store action listener. You might see other people calling this a on-click action or store action handler. I like to use the similar name to what the actual type is. Helps me remember that that's an action listener type. But remember, that's your choice of what to call that class. Handler, event handler, what happens when I click, that's the choice. But once I define that, that's what I have to use when I say, oh, I'm making a new one of those to handle my button store action. Alright, and when I did that, when I typed implements action listener, I got some red squigglies. First of all, I had to make sure that action listener got imported. Right there, action event. And then, after it knew what an action listener is, an abstract class that is implemented by my class, then I again let Eclipse add the unimplemented methods, action performed, put it in some code here, and this is what then I added to that code. This override, remember what this does. This makes sure that this indeed is the actual exact name of the method that needs to be implemented, if I'm deciding to implement action listener, with the exact type, correct type of the variable passed to the action performed method required in an action listener. The actual name of this variable is up to me, and I'm just, because I'm lazy, I don't want to change that, I'm going with arg0. I don't really do anything with arg0 at this point, but I could actually find out if there were different buttons clicked I could find out which button was the one that clicked me. But since all I care to do is I know that this is the button that is the only one calling this action called store action listener, I don't have to worry about what argument is being sent as an event, unless I want to do some debugging. Alright, now I'm thinking about, as I think of this code, I want to take what data they have given to me in those text boxes, those text fields, and I want to build a string that's going to become the data that goes into my block in my blockchain. So don't worry about the blockchain yet. I just want to build a string that represents the data that's in those text fields. And the way I'm doing it is doing a get text of each text field, and I'm concatenating it to the data string. In case there is something already in the data string, I make sure to put a comma between them. Notice I'm not just adding a comma at the end of everything, because I don't want that last thing to end in a comma. That's just annoying, and it won't, if I ever process this, it'll create another empty element at the end of the array when I split this back up into its separate strings. So here's a quick and easy way, counting through the number of text array elements, the J text field elements being held in that txt array. Let's again look at how that txt array was built. As I was creating my labels, I made sure to create a txt array at position I, and there is where it's creating a new J text field. As I was creating my labels, I was creating these text fields. Because they're for user input, they're going to be showing up as blank with a width of 20 is a convenient width. And remember, way at the top, I define that as an array. We want to keep practicing the use of arrays and more. There's where I'm defining that as an array of text fields. And even though I'm making room for that number, it's the same number of JText field objects as there are labels, because I want to have a JText field to go with each label, this does not create my JText field. It creates an array holding pointers to that many text fields, and the pointers are null until I assign a new text field into that position. So this is the space to hold a handle or pointer to a new text field. This is where I'm actually creating a text field, but of course it's not going to appear unless I also add it to my container here. So let's just add a comment here. This is where I create the text field. And this is where it gets added to appear. So back to my GUI. As each label is created, all those text fields are showing up. When I click the button now, the action that happens here needs to go read what was in each text field 0, 1, 2, 3, 4, 5. However many labels there were. And when I get that data, I read it from that particular text field that's being held in txt array I. I get the text and add it to the string. And at this point, I'm not doing anything but a debug message, but I will be adding that to a blockchain. So at this point, I'm just doing a debug message. Let's take a look now at my blockchain. I've done a little bit of adding to it since I showed you on Monday. So here's my crypto block, where I've defined the type of data that's being held in there. The empty constructor, I don't think I'm going to need that. I did a little bit of work on the constructor that takes parameters. And as I was walking through this, I'm thinking, you know, do I need to have somebody give me the timestamp as a parameter? Or can I just do this? Just assign the timestamp of my block to be the time that this block got created. So would there ever be a time that I would want to create a block giving it a different timestamp? At this point, I'm letting my block creation ignore the timestamp being sent as a parameter. So I'll put a comment here, ignoring timestamp parameter. And I'm thinking, although I initially had thought I need to send it as a parameter, I'm thinking as I'm implementing it, you know what? Let's just assign the time to a long current time. And because the timestamp has been defined as a string, just because they're easier to deal with when doing hashes, which is going to be used to validate my blockchain, I turn that into a string using this method. Put the timestamp, because I just know from the code this returns a long. In order to convert the long to a string to be stored in my block, in my link of the blockchain, I do the long.toString. There's the get my system time. Because you see I'm actually doing the get time here, this actually is unneeded, and I can see I'm actually not using that variable. I'm just going to comment that out because I was trying that out first and I realized I can just put that in one line. Now this is going to be given to me as a parameter, as a string. And now comes a time where I have to actually, this mine block is going to calculate my hash and make sure that it's a hard hash based on the difficulty. I'm going to be mining the block, and I just noticed right now that my difficulty has not been assigned, so I better do that before I do the mining. So I'm going to do a this.difficulty equals the parameter handed to me. Now when I mine, I'm going to need to use that when I do my mining. And right now, my mining is not complete, but let's start building the pieces that I need to do my mining. I'm going to need to calculate the hash of the data in my block. This is critical to how blockchains work. Right? This whole mining and applying a hash is how they get their strength of not being very easily or make it impossible to fake the data in a blockchain. Because the mining and trying to change the data takes a lot of work, but validating a chain is hardly any work at all. We can tell we have a valid chain, and if someone tries to make an invalid data, it's a lot of work, so much work that they can't get it all done and fake out all the nodes that are holding copies of my blockchain. In order to do a hash, calculate the hash of a blockchain, as I was looking at the example code, they had given us the actual code for this utility that helps to calculate the hash or a encryption of my data into a unique string of characters. And rather than write that code, I'm going to take that code, put the proper citation of where I got the code, so I'm not doing code plagiarism, and I'm using that code, and let's just walk through what that code does. It's a class that's just a utility class. All this class is for providing a way to convert a string into a hash. Very much like the math class. Okay, so the string apply SHA-256, a particular message digest format. And of course, the root of all the code is given to me, built into java.security message digest. It takes a string. We're calling it input as a variable. There's our exception handling. I do a try, and what I'm trying to do, can I get an instance of a SHA-256 message digest, calling it digest. And now to actually generate some hash, which is an array of bytes, I do a digest of my input, getting the bytes of the input in a particular format. I make a new string buffer called hex string, and in a loop here, one by one, I convert the hex of my hash ANDed with FF, so basically taking only what's in the 16 bits of the hash and putting a leading 0 in it, and then appending it to my hex string buffer. So all of this being done in the try part of my exception, and if that all works, I return a string representing the hash of my string input. All that you care about is that I get a hash that is a string. And that's been given to us, and it's not terribly long code. And just like you'd find out if you read someone else's code, you learn a few things here. He's using a string buffer, and in that string buffer, as this message digest returns this thing called a message digest, it returns a byte array. That's just, they decided that a digest returns a byte array. But since we want to turn that into strings, we create a hex string of a type string buffer. Not sure why he didn't use string, but I see in the explanation it's maybe got certain features better than a string, and I can learn about that, or I can just say, yeah, this code works, let's try it. All I care about is I get a string back from this function. This return hex string returns me a string, and I don't really care how we did it. All I care about is it gives me some string that if I change the data being hashed, I get the type of string that I'm looking for, with the difficulty that I want, having to do with leading zeros in that hash. Okay, now back to my block. This calculate hash is just a quick way of just give me the hash of my data in my block, which is a hash of the data that's in there, plus the timestamp, plus this very important variable called the nonce. And of course, because the validity of this block also depends on the validity of the previous block, I am hashing as well the previous hash, making all my links chained in their validation. So if someone tries to put fake data anywhere in my blockchain, they have to basically recalculate all the hashes for the entire blockchain in order to try to corrupt the data, making it impossible to corrupt the data. Now at this point, I have not yet done the mining, but I have written down in comments what I want to do to mine my block is I keep calculating the hash until the hash shows up with leading zeros, the same number of leading zeros as I have specified in the difficulty setting of my block. And how do I get my hash to change? I keep incrementing the nonce until I get a hash that comes out to have the number of leading zeros I'm looking for. So that nonce, this loop here, The only thing it does is keep incrementing that nonce until I get a hash matching the difficulty. And as you can see, it's harder to get a very specific hash that has so many leading zeros. I have to do more and more work mining, recalculating the hash, which is not an easy algorithm. Purposely, it's a hard algorithm, taking lots of CPU power to calculate that. And I'll discuss that in the next video, but you also have that helpful page online explaining the message digest. I've given you this link in the forum discussion. You have to read through that code, implement the code, and that's you right there. Okay, send any questions, work with your partner. On Friday, we'll be checking out a GUI and a button click that puts data in a block and mines it to have the correct hash, and then adds it to your blockchain.